Continuing along on chapter 6, right? All of the data that we have says that in the last 800,000 years, and that's longer than we've been alive as humans, right? Humans have only been a species for about roughly 200,000 years, give or take. But right now, the average temperature of our atmosphere is higher than any time in the last 1,500 years. So it's warmer. It's warmer and it's getting warmer. And here's why we talk about anthropogenic climate change. Right? What are the things that would make climate warmer, make climate cooler, the things that affect it, right? The forcing factors like solar output, all of that. There is no natural factor that we can find that would explain this. In other words, when we look at why is temperature getting warm, well, you say, well, there's more carbon. But what is releasing more carbon? What is the cause of this? We can't find evidence of anything other than man-made emissions. So here's an example. You look at the time here, this goes back 800,000 years. And this red line is temperature. So you can see that we've actually been cooler for a long period of time, and then warmer, cooler, warmer, cooler. But if we zoom in right here to this last little section, this last roughly, I would say probably 1,500 years, right? It's been much colder than today, much cooler. We don't really see us catching up to today's average temperature until today. So until then, it's been much cooler, right? This is various things that could affect climate. So this is the pattern of El Nino as we talked about, right? The temperature swing that changes the world's climate for like a year. This is sunspots activities. Maybe that might be the cause of it. Black spots in the sun. What about volcanoes? So when a volcano erupts, it can make the world cool for a year or two. We can look, we can see there's that. But this is the current the pattern we see for warming since basically the last 100 years. And none of these match that pattern. There is nothing here to indicate this. So that's when we say anthropogenic climate change. Remember, science is based on the best data available. Could there be something out there that is causing climate that is not man-made? Possibly. Maybe we haven't found it yet. But all of the data we have today suggests that we are the cause of it. That increased emissions of carbon from human activities is the only thing that matches this. The rate of carbon released matches this. None of these do. So then climate change is bad, right? It's a bad thing. Positive and negatives. Here's the thing. It depends on who you ask, because Earth doesn't care if it's good or bad. Earth is not a person. It doesn't have emotions. Climate is what it is. If it's good or bad depends on who you ask. Some areas are going to see better farming. Northern Canada is going to have a longer growing season and less colder winters. Alaska is going to become much more hospitable. Large parts of Asia will become better. In fact, the area on the Arctic Ocean, which is currently frozen for half the year, are now going to be able for more fishing and shipping, much more trade. So if you live in Canada or Alaska or Norway, it's not exactly a bad thing. Canada is in some ways embracing climate change. It's going to benefit them in some ways. But what are the negatives? And the negatives are just far more extreme. Sea level rise around the world will displace millions. New York City is on the Atlantic coast. If the oceans rise as far as they could by melting the ice in Antarctica, it'll be underwater. Most of Florida will disappear. Large parts of Asia, heavily populated areas, entire nations that are islands in the Pacific or Atlantic Ocean will go underwater. Weather will become more extreme. Not only will the earth become warmer, but the storms that we have are going to be much more extreme. We're going to have hotter summers, colder winters. We're going to have animals go extinct because as climate changes, so does their habitat. And animals don't have the luxury that we do. If their food runs out or where they live changes too much, they just can't pick up their car and move. They go extinct, right? We're going to see changes in wind and rain patterns. We're already seeing that in some ways. Here's an example of the Arctic Ocean. This right here is the area that is frozen in September. And this is between roughly 1980 and 2000. So in the winter, the ice was frozen all the way here through. It was impossible to sail through here because it was frozen over. But in 2012, you can see right here that now the ice melted and it is possible to sail through here. Why is this important? If you are sailing from China or Japan to Europe, this is half the distance of the current shipping routes that go around Africa. It saves time and money. This, from Europe to Asia right through here, much faster. And in fact, the amount of trade is important. Look at this. In 2010, only 4 ships made this journey, but in 2013, 400 ships used the route. So there's a lot of that benefits to that, but there's also a lot of negatives. We're also going to see increased oil mining, natural gas mining, and that has some very negative environmental aspects as well. Another thing that we're seeing are glaciers are melting. So these are various glaciers around the world, and you can see that the average length of glaciers is getting much shorter. Here's a glacier in 1941 in Canada. Same shot in 2015, and you can see how much has gone away. There's a national park in Montana called Glacier National Park. Beautiful, has many glaciers. They will be all gone, melted in your lifetime. So, how do I know this? How do I know to tell you that we're going to have this change? And one of the ways we do this is by making models, mathematical simulations. We know how climate acts, right? I haven't made you do the math, but you've seen all these formulas. And we can predict weather in many ways because it's just like doing an equation. If you have the data and you know the equation, you should be able to plug them in and get a result. And that's how they actually predict the weather. Now, the question or the issue is, do you have all the data? Weather is very complex. There are so many variables. So imagine having an equation with 10 variables, 10 things to solve for, and an equation that had 10 million variables. And if one variable throws the whole thing off, that's why they're not as certain. So weather forecasting, right? You think about the weather, they can actually be pretty accurate for about 2 days. They can tell you what the next 2 days are going to be pretty close. But after that, not so much, right? Well, we use somewhat of the same thing, right? We have these models. We know how Earth's systems act. We have data in the form of various measurements. So we plug them in. But that can all change too. For instance, carbon change. In the future, if we're modeling what will happen in the future, right, based on the data, what happens if we reduce climate or reduce carbon emissions? That could throw everything off. For instance, no one would have foreseen 2020, right? The emissions in 2020 are going to be anywhere from 2 to 20% lower than they would have been normally, based on everyone stopping to work and factories shutting down. And how is that going to affect the future? Here's an example. Right here, we have 2 maps of the growth of temperature. This is low growth and high growth. And what this means is, starting today, we know what carbon has done in the atmosphere, how much carbon we put in. But what happens to how much? If we continue to add as much carbon as we always do, that's high growth. We'll get this model. But what if we find ways to limit carbon or make more energy efficient cars and we have low growth? And you can see here we might not hit the worst effects. So in some ways there is a lot of uncertainty because we're still not quite sure how that's going to play out. This is a map that's going to show the change in runoff, how much water will enter lakes and rivers based on rainfall or snow melt. And you're going to see that certain areas here are going to see less water, more drought. Certain areas will see much more, which might lead to flooding. But if you're a farmer in this area, it's going to be very difficult, isn't it? And this is going to change the way we grow things. What about temperature? If we don't change things, what we predict, if we keep on putting in carbon as much as we do, by the year 2070, which many of you will live to see, we are going to have how many days above 95 degrees? We're going to see an increase in Chicago, maybe 15 more days a year over 95 degrees. Another half month of very hot summer. Look at down here in St. Louis or Southern Illinois. Almost 35 days extra over 95 degrees. That's a huge switch. This is one actually might happen. Think about this. The last 3 Mays have been the wettest Mays on record. If you thought that this last May it rained a lot, you were right. This May was the wettest May, most rain last year and the year before. And look at 2011 back there, the 6th. There's actually this trend. May has become a wet month in Chicago. Usually in May it was cool and somewhat dry, not that wet. But now it's so wet, we're seeing issues that we never thought of. Like the Chicago River a couple of weeks ago actually flooded the Riverwalk in Lower Wacker Drive. So these are things we're going to have to deal with. So we're going to end this with this idea of stabilizing climate. I'm going to pause right here and come back with the last little bit in just a moment. I need to get a drink of water.